So this is 2012, paper 2, question 12. It's one of those two optional questions for internal papers. So now we have Grace would like to give a sum of money to a charity organization each year for 10 years. She decides to give 120 in the first year. So that means our first term, or A, is equal to 120, and to increase her contribution by $10 each year. So are we calling this an R or a D? So since this is the amount of money that is being added each year, it means this is our D. So this makes this entire thing an AP, an arithmetic progression. So now, how much does she give in the last year? Remember, we have 10 years here. So 10 is the 10th year is the last year. So what this question is asking you to find is actually the 10th term. So the nth term of an AP is given by A plus, open brackets, n minus 1 multiplied by D. So to find the nth term or the 10th term, you simply put a 10 on the n and then a 120 on the A plus 10 minus 1, and then our D will be 10. So this is easy. We have 120 plus 10 minus 1 is 9 multiplied by 10, that's a 90. And then when you add these two, this is a 0, this is 11, this is $210, of course. So this is the amount of money Grace pays in the last year. So now, how much does the charity organization, I think, receive from her altogether? So in short, what the question is asking you to do, as you may have guessed, is to find the sum of the 10th term, like the sum of the first 10 terms, so to say. So you can say S sub n. Remember, this is an AP. So S sub n is given by n over 2 square brackets. We have 2a plus n minus 1 multiplied by d. So to find the sum of the first 10 terms, you can just put a 10 there, another 10 there, divided by 2, and then our A is 120, and then our N is 10, minus 1, our D is 10 as well. So now this into this is 5, and then this times this will be 240 plus 10 minus 1 is 9 times 10, this will be 90. And then we can have our 5, and then 0 plus 0 is 0, 4 plus 9, that's a 13, that's a 3. And then 5 times 0, 0, 5 times 15, that's a 5, carry 1, this times this, 5 again, which is a 15 plus this, 16. So we have this as the sum of money this man would have paid at the end of everything. So a geometric series has first term 27. So in this case, we've been told what kind of a series this is. So our first term, or A, is equal to 27, and then the common ratio is 4/3. Find the least number of terms the series can have. Least number of terms the series can have if its sum exceeds 729. So this is the data. We have to solve the inequality for n. And remember, n can only be an integer. It has to be a counting number. You can't have decimal numbers. So whatever you have, make sure you round it up. You don't just round it off. So let's say you have 2.001. You have to round it up to the to this. You have 3.9. This rounds off to 4. As long as there is a point, you have points, maybe 0, 1, regardless of how big this number is, you always round it off to the, up to the next number, to the next natural number. So in this case, we can just say the sum of the nth term is given by r to the power n minus 1, then everything over r minus 1. If you want, you can swap these two. Just make sure that when you swap the numerator like this, you do the same thing on the denominator like this. So remember that we have this situation here. Whatever this is, it must be greater than 720. So find the number of terms, the least number of terms the series can have if its sum exceeds this. So the sum here must exceed 720. So whatever this is should exceed this. So we can say A is 27, and then R is 4/3 raised to the power n minus 1, everything over 4/3 minus 1, and then this must exceed 720. Whatever this is must be greater than that. So now we have 27. I think I'll need a calculator for this, because I can see we have logs. So this multiplied by this minus that, so that's a 3 minus 4. This would be 1/3, and this is greater than 720. And then this is like saying this divided by that. So it's like dividing this by that, and then it's like multiplying by the reciprocal of this. So don't just say this times that. I know that's the case, but you must always watch out. So this times that will be 81. Like this times that is 81. And then you have 4/3 raised to the power n minus 1 is greater than 729. So let me see if I can divide both sides by 81 to make this thing easier. Yes, this is a 9, so we can divide both sides by 81 to simplify it. So this side we have 4/3 to the power n minus 1. This into this is 9. Then I can simply take this to the other side. Then we have 4/3 n is greater than 9 plus 1. So we have 4 over 3 to the power n is greater than 10. So now there is no way I can write 10 in terms of 4 over 3. So in this case, I have to introduce either the natural log or the common log. So for me, I'll go for the natural log so that I can easily use my calculator. I'll introduce the natural log to both sides, and this one will be n natural log 4 over 3. Then this is greater than natural log 10, and then I can divide both sides by natural log 4 over 3, natural log 4 over 3, and then n will be greater than, you can just punch this one on your calculator. On mine, this is that's 2.3026, and then for the denominator we have 0.2877, and then the quotient is 8.002. And as you can see, this is not a natural number. So you want to make it a natural number, but remember you want to round it up because we want to find the value of n for which the sum exceeds this. So remember that n is greater than 8.002. So the value of n, the smallest value of n which can satisfy this statement here, where the sum exceeds 700, and that is whatever natural number which is next to this, which is above this. So that natural number is a 9, I think. You don't have any other number other than a 9 which has those properties. So if I was to use an 8, I'll realize that the sum will be slightly less than this 729. But the moment I go above 8, I use a 9, for example, which is the smallest possible number to give me these properties, then I'll be able to get the desired answers.